my KCET 2026 aspirants, so welcome back to our Sankalp KCET 2026 series, and in today's class we are going to solve the previous year questions of the chapter solutions. So I have done two parts video solutions and I have explained all the concepts in this chapter. So I hope the concepts are clear, and I want all of you to sit with your notes so that you know all the formulas that we are going to discuss in this class and you are able to solve the question. So this video will be having 30 questions from previous year papers, and we have included from 2025 to 2016 question papers. Okay, so what you have to, and I have segregated them topic wise so that you can understand which topic more number of questions are being asked, and you can identify the important and the non-important topics, right? And I want all of you to see the question, pause the video, solve by yourself, and then check the answer. Okay, so this is a request so that you can just understand how much you have the grip over the chapter, right? Okay, so let's see the first question here. Which of the following methods of expressing concentration are unitless? So this is a KCET 2025 question. So you know that we have certain so we have certain quantities which are unitless. One of them is definitely mole fraction. So if you remember what is the formula of mole fraction, okay, so mole fraction formula is NB by NA plus NB. Right, so numerator also have number of moles, denominator also have number of moles, so number of moles and moles will get cancelled, so it will have not unit. Similarly, mass percentage, what is the formula? Mass of the solute by mass of the solute by mass of the solvent. Right, again here gram and gram, it will get cancelled, so these two will have unitless, so option number D or 4 is the correct answer here. Next I have an aqueous solution of alcohol contains 11 gram of water and 414 gram of ethyl alcohol. The mole fraction of water is, right? Let's see now question number 2. An aqueous solution of alcohol contains 11 gram of water and 414 gram of ethyl alcohol. The mole fraction of water is. So you can see that we have 11 gram of water. So what is the number of moles of water? 11 by 18. Right, then what is the number of moles of ethyl alcohol? I'm just writing ET. Okay, ethyl alcohol given mass by molar mass 414 divided by, let's calculate the molar mass of ethyl alcohol, C2H5OH. so I have 12 2s are 24 plus 5 plus 1 6 30 plus 16, right? So I have 30 plus 16 46, so that is 46. Now if I just see 9 6 are 54, so this is equal to 9. Right, so I've got the number of moles of water and the number of moles of ethyl alcohol. You have to find the mole fraction of water. So what will be the mole fraction of water? It will be the number of moles of water divided by number of moles of water plus number of moles of ethyl alcohol. What is number of moles of water here? It is 11 by 18, and here I have 11 by 18, that is number of moles of water plus number of moles of ethyl alcohol, which is 9 here. Now if I solve this, I have 11 by 18 whole divided by 9 8s are 72, 9 1s is 9 plus 7 16, so 160. So I have 11 plus 162 by 18. Okay, so if I solve this, I will be getting here, let me continue. So I'll get 173 by 18, so 11 by 18 the whole divided by 173 by 18. 18 I can cancel, and I will be left with 11 by 173, right? So now if I solve this, simple division I can do, 11 divided by 173, so I have to put a decimal here, then right, then I'll put a 0 here, then another 0 here, then another 0 here, and then if I see 6 3s are 18, 6 7s are 42, so I'll get somewhere around 0.06, so that is option number C is the correct answer. Very simple calculation based question. Okay, next you have this question number 3. This is from 2025 paper. Variation of solubility with temperature T for a gas in liquid is shown by the following graphs. So if you remember, when I have taught you about the solubility, we have two categories there: solubility of solid in liquid and solubility of gas in liquid. Solid in liquid depends on which 3 factors, comment down and tell me, or depends on which 2 factors, comment down. And solubility of liquid in gas depends on 2 factors, that is temperature and pressure. So with pressure it is directly proportional, and with temperature it is inversely proportional, right? Solubility of a gas in a liquid is inversely proportional to temperature. So that means what? When temperature increases, solubility will decrease, but here it is increasing and then decreasing. So this is not the correct. Temperature increasing, solubility increasing, no. Temperature increasing, solubility has no effect, no. Temperature increasing, solubility decreasing, yes. Right? So option number B is the correct answer here. Next, solubility of gas in a liquid increases with. So just now we have discussed, it has 2 factors. If temperature increases, solubility decreases, pressure increases, solubility increases, right? So solubility of a gas in a liquid increases with decrease in temperature, right? So I can say increase of pressure and decrease of temperature, option number A here. Okay, next, N2 gas is bubbled through water at 293 Kelvin. How many moles of N2 gas would dissolve in 1 liter of water? Assume that the N2 exerts a partial pressure of 0.987 bar. Okay, the KH value of N2 is 76.48 kilobar. Okay, fine. So we have this from Henry's law question. What is the general formula? Henry's law formula: P of the gas is equal to KH into mole fraction of the gas. What is the partial pressure of the gas given to me? So let me write down all the data that is given to us. We have 1 liter of water. Okay, so I can write mass of water. Now see here, this is important. 1 liter of water is 1000 ml. Right? So I can just writing here, volume of water given to me is 1 liter. Okay, or I can write 1000 ml, right? And density, you should remember, of water is 1 gram per ml. Okay, then what is the mass of water? Density, we know density is equal to mass by volume, right? So what is then mass? Will be density into volume, right? So what is density here? 1 gram per ml. And what is volume here? 1000 ml. I can cancel, I'll get 1000 gram, right? So this I'm erasing. So what is the mass of the water I got here? 1000 grams. Okay, now let me just erase this part. So mass of the water is 1000 gram I got. Next, what I have here? I have got that how many moles of N2, assume that N2 exerts a pressure. So what is the pressure of N2? Pressure of the gas is 0.987 bar. Next, I have here KH value of N2. KH value is 76480 bar. I can just converted this kilobar to bar. Okay, so now I can substitute the formula here, Henry's law formula, right? So I can write that pressure of the gas is how much? 0.987 bar, right? Okay, next, KH value is 76480. Okay, into mole fraction of the gas. So in mole fraction of the gas, I can represent it as number of moles of N2 by number of moles of water. If you remember, I have told you that in dilute solutions, we can ignore the number of moles of the solute in the denominator, right? So what I will get here, I can further find out the number of moles of water also first. Number of moles of water will be mass by the molar mass, right? 1000 gram divided by 10, so it is 55.55. Okay, so you can just keep it as 1000 by 18 also. Let's see. Okay, so I have 0.987 divided by 76480 into number of moles of N2. Okay, then I have 1000 by 18. Okay, so I'm just getting this N18 here. Now let me just solve this N by N2. So I will get here 0.987 into 1000, right, divided by 76480 into 18. right? So now this 987 into 1000 will become 987 divided by 76480 into 18. Now can I cancel this? 3 6s are 18, I have 3 3s are 9, 3 2s are 6, 29, right? So for easy calculation, just I can round it off to 330. Okay, so I'm rounding it off to 330 divided by 76480 into 6. Now again 2 3s are 6, 3 2s are 6, and I have 3110. Okay, and then again I can cancel 55. So I have got finally here 55 divided by 76480. Right, now again I can cancel with 11, 5 11s are 5 1s are 5, 2 5 5s are 25, again 14, so 10, I have 4 8, 9s are 45, 1 5 9 6, so 5s are 30, 3 10 14, 26, so I got 11 by 15296. Okay, so now you have to divide this part definitely. Okay, so just a minute. Yeah, so if I divide this 11 by 15296, okay, so you will be getting around 7.16 into 10 to the power of minus 4. You can just do this division, it will take certain time, divide it and find out, you will get option number 2 here. Okay, next moving to question number 6, Henry's law constant for the solubility of N2 gas in water at 298 Kelvin is 1 into 10 to the power of 5. So I have been given with KH value as 10 to the power of 5, okay, atm. Okay, next the mole fraction of N2 in air is 0.8. okay, so we know the mole fraction of N2 in air is how much? 0.8. The number of moles of N2 from air dissolved in 10 moles of water. What is the number of moles of water? 10. Okay, at 298 Kelvin and 5 atm pressure. So what is the pressure total here? 5 atm. Okay, so we know that Henry's law says pressure of the gas is equal to KH into mole fraction of the gas. So what all things I have? I need to calculate the number of moles of N2 that will dissolve. Now just imagine this scenario. See, it is like this, that you have a container, okay, and here you have 10 moles of water. Here there is N2. Okay, how many moles of N2 is there in the atmosphere? 0.8, and the pressure, atmospheric pressure is 5 atm. Okay, but if you remember, the Henry's law says that the solubility of a gas in a liquid depends on the pressure of the gas above the liquid. So I want to know the pressure of N2, not the total pressure, not the atmospheric pressure. I want to find the pressure of N2 above the solution. Right, how much pressure of N2 is there? So how to find that? Here comes a new formula. Pressure of the gas is equal to mole fraction of the gas into P total. Okay, so now if I want to calculate pressure of N2, that will be equal to mole fraction of X. What is the mole fraction? 0.8, and total pressure is 5. That gives me 480. Okay, so I have calculated now this Pn2. Okay, KH value is given to me. I have to find this mole fraction of N2. So I can write down this P of N2 is equal to KH into mole fraction of N2. And for that I will write number of moles of N2 by number of moles of water. Right, now if I solve this, this becomes 4 into KH value is 10 to the power of 5. Number of moles of N2 I have to find out, right, and number of moles of water is 10 to the power of 10. Okay, so this can get cancelled. I will get 4 into 10 to the power of minus 4 as number of moles of N2. Okay, so that is your option number A here. Clear? Next, choose the correct statement. So KH value is same for a gas in any solution. So KH value depends on the solubility, right? And different solutes are different, have different solubility in different solvents. So KH value is not a constant value. Higher the KH value, more will be the solubility of the gas? No. Okay. Higher the KH value, lower is the solubility. We have studied this. Next, KH value increases on increasing the temperature of the solution. KH value increases on increasing the temperature of the solution. Now see, how is this related? Again, if you see here, I can write KH from this formula is equal to P of the gas by mole fraction of the gas. And mole fraction, when I talk, it represents solubility. Okay. Now when you increase the temperature, what happens? Solubility decreases. If I increase the temperature, solubility will decrease, and if solubility decreases, KH value will increase. So I can say that if I increase the temperature, KH value is also increasing. So yes, this is a correct statement. Next, easily liquefiable gas usually have lesser KH value. See, this is a most of the cases it happens like this, but there is no direct relation in this. Okay, so that is why this is not the most appropriate answer. Okay, we'll move to question number 8 here. KH value of argon, carbon dioxide, formaldehyde and methane are given the increasing order of solubility of the gas in liquids. So first let us write down the values here. So argon, that is your number 1. Then you have carbon dioxide, which is your number 2. Then you have formaldehyde, that is your number 3. And then you have methane, which is your number 4. Okay, and the values are given 40.3, 1.67, 1.83 into 10 to the power of minus 5. Then you have 0.413, right? Okay, now if you see this one, third one, this is having the least KH value, right? This means highest solubility. So third one will have highest solubility. I can have these two options. Next I have least value is for option number 4, right? So highest solubility will after 3 will be 4. Okay, then you will have 2 and then 1. So option number A is the correct answer here. Next, we'll have a question from Raoult's law here. The vapor pressure of pure liquid A and B are given to you 450 and 700. So before that, let me just revise what is Raoult's law. If you remember, P total equal to P naught A XA plus P naught B XB. That is the Raoult's law. And here one more formula if you should know is mole fraction of XA plus XB is equal to 1. Right? Fine. Now the vapor pressure of pure liquid A and B are given. Okay, so what is the formula given to me? So I have been given with P naught of A, which is how much? 450, and I have P naught of B, which is 700. Okay, if the total vapor pressure of the mixture is 600 mm of Sg, what is P total here? 600. Okay, now we have to find the composition of the mixture. So let me assume that mole fraction of A is X. Then what will be the mole fraction of B? 1 minus X, because we have XA plus XB is equal to 1, right? Or if just let me put it XA, this is also 1 minus XA. So let's put that formula now. 600 will be equal to P naught of A, okay, then P naught of B. Okay, let's solve this. So I will get 450 XA plus 700 minus 700 XA. Okay, and here I have 600. Next, if I see 450 minus this one will give me 250, right? I can write minus 250 XA plus 700 is equal to 600. Now if this 700 comes to this side, okay, so I will have minus 100 is equal to 250 XA, okay, and then if I solve, I'll get 2 by 5 is equal to XA, and then XA I have 0.4. If XA is 0.4, then XB will be 1 minus 0.4, which is 0.6. So I have XA 0.4, XB 0.6, option number A here, right? Okay, just a minute. So now let's see question number 10 here. Solution A contains acetone dissolved in chloroform and solution B contains acetone dissolved in carbon disulfide. Their type of deviations from Raoult's law shown by solution A and B. So if you remember, I have given you a table where I have given you the examples of both positive and negative deviations, right? So if you remember that, when you have acetone and chloroform, okay, acetone, okay, acetone and chloroform. So what happens here, we have a strong interaction, okay. So due to which there is a strong attraction, means there is negative deviation, okay. So first one will be negative deviation and second one will be positive deviation, option number D. You can remember the examples directly here. Next, a mixture of phenol and aniline shows negative deviation, okay. What is the reason for that? So when you have phenol and aniline, okay, so if you see, this is phenol, okay, and we have, sorry, I'll draw this side, and we have aniline. So let me just show you like this. I have aniline and you have phenol here. So what happens, there is a hydrogen bonding between O and H here and this N and H. So due to this hydrogen bond, intermolecular hydrogen bonding, there is a negative deviation. Next, relative lowering of vapor pressure of a dilute solution of glucose dissolved in 1 kg of water is 0.002. The molality of the solution is. This is important question, and here I will introduce you to a new formula, okay. So we know that relative lowering of vapor pressure is delta P by P naught is equal to P naught by P minus by P naught is equal to XB is equal to NB by NA, right? This we know. Here I have, first of all, see, relative lowering of vapor pressure is given to me is this much. So I can write delta P by P naught is equal to 0.002, right? And I also have delta P by P naught is equal to XB. So I can say from these equation that XB is equal to 0.002, right? Now it is given 1 kg of water, right? 1 kg of water is there. Now I have a formula to relate between molality and mole fraction. What is that formula? Molality and mole fraction formula is M molality is equal to XB by XA into 1000 by MA, where MA is what? Molar mass of solvent. Molar mass of solvent. Please note down this formula. This I haven't discussed in the lecture. This formula you should be knowing. So now let's solve this. If I have XB value as 0.002, then what is XA? 1 minus 0.002, or that will be 0.998, right? So I will get XA value as 0.998, okay. So now I can calculate molality. What is XB here? 0.002. What is XA here? 0.998 into 1000 by 18. Molar mass of water is 18. Now can I consider this 0.998, okay, as 1? I can consider this as, or I can just write down like this, 2 by 998 into 1000 by 18. I am considering this as 1000 only. 1000 I can cancel. I will have 1 by 9, and 1 by 9 is equal to 0.111. Okay, option number C here. Let's see the next question here. Vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is, and the vapor pressure of pure water at 100 degrees Celsius is given to you. So now we have here mass of the glucose, okay. So I have mass of glucose which is 18 grams, and then I have molar mass of glucose which is 180 grams. Then I have here number of moles of glucose. So if I solve this 18 by 180, that will give me 1 by 10 or 0.1. Next I have mass of water, okay, and this one will give me 178.2, and then I have molar mass of water which is 18 grams, right? Then what is the number of moles of water here? 178.2 by 18, that is equal to 9.9. I got this one. Okay, now if I solve, what formula I have, this is the formula. So I have 760 minus P by 760 is equal to number of moles of glucose, which is 0.1 divided by this is 9.9, right? Now I can solve this is 760 minus P by 760 is equal to 1 by 99, okay, or I can roughly write it as 1 by 100, right? So if I got to solve this, then I will have 760 by 100, which is equal to 7.6. Now if I solve this one, 760 minus 7.6 will be equal to around 752.4. okay, so that is your option number B. Clear? Next we'll move to question number 14. Which one of the following pairs will show positive deviation? Positive deviation means what? If you know, positive deviation means less attraction or weak attraction. So benzene and methanol will have weak attraction because methanol have strong hydrogen bonding, but when you add benzene to it, the hydrogen bonding of methanol is destroyed. What happens here? The hydrogen bond of methanol is destroyed, right? Okay. Next we'll go to elevation in boiling point. Next colligative property. The rise in boiling point of a solution containing 1.8 gram of glucose in 100 gram of the solvent is 0.1 degree Celsius. The molar elevation constant of the liquid is. Molar elevation constant means they are asking you about Kb. Okay, so we have this formula for elevation. What all values I have given? The rise in boiling point means your delta Tb is 0.1 degree Celsius. Okay, then I have 1.8 gram of glucose and 100 gram of solvent. Okay, so I have here W2 is 1.8 gram. The molar mass of the glucose is 180 gram. Okay, and then I have 100 gram of the solvent, 1.8 gram of glucose in 100 gram of the solvent. So what is the mass of the solvent? 100 grams. Now let's solve this. So I have here delta Tb is equal to Kb into m. So I have delta Tb 0.3, Kb I have to find out. Molality is 1.8. That is the mass. What's the molar mass? 180 into 1000. Okay, then I have the mass of the solvent as 100. Okay, so I have here 10, right? I can write this one as 18 by 180, so I have 1 by 10. Okay, just a minute. Sorry, here I made a small mistake. This is 0.1. Okay, so this 10 I will multiply. What is the value of K here? 1. So that is your option number D. Okay, fine. Next, moving to question number 16 here. 180 gram of glucose is dissolved in 1 kg of water in a vessel. The temperature at which the water boils at 1.013 bar is, you have to find out. Kb value is given, boiling point of water is given. So I have here the mass of the solute. W of the glucose is 180 gram dissolved in 1 kg of water. So what is the W of the solvent or water? I can write 1000 grams or 1 kg, right? Next I have temperature at which, this pressure is of no importance here. Boiling of water is already given. T naught B is 373.15, right? And I have Kb given 0.52. Okay, now let's solve this. Sorry, 1 second. Yeah, now let's solve this question. So we have this formula. Okay, I have this formula, delta Tb, right, is equal to Kb into m. What is delta Tb here? I have delta Tb is equal to Tb minus T naught B, right? The boiling point of the solution will be more than the boiling point of the solvent. So what is the value of Tb here? I have to find out. T naught B is 373.15. Then I have Kb value, which is equal to 0.52, and this molality I have 180 gram of glucose. The molar mass of glucose also you should know, molar mass of glucose is also 180. Okay, then I have 1 kg of the solvent, right? So I have to just solve this one. This term becomes 1. Okay, so I have this one, TB is equal to 373.15 plus 0.52. Okay, so I have 5, 6, 7, I have this one, and then I have 373.67, which is your option number D. Okay, next, this question, the solute X dimerizes in water to the extent of 80%. Okay, dimerizes means association. So I have, this is from Van 't Hoff factor, alpha association given to me is 0.8. 80%, 80 by 100 I have taken, that is why I am getting 0.8. So I can write 80% is equal to 80 by 100, that is equal to 0.8. Okay, now 2.5 gram of X is 100 gram of water, increases the boiling point by 0.3 degree. So I have delta TB is equal to 0.3, and I have mass of the solute. W of the solute is how much? 2.5 gram dissolved in 100 gram of water. So what is W of solvent? 100 grams. Molar mass of X I have to find out, and Kb value is 0.52. Okay, you have to find the molar mass of this one. Clear? So let's solve this. So first of all, if you remember, when there is ionization, when there is dissociation or association, at that time what we have I value, or sorry, we have the formula like this, delta TB is equal to I into Kb into M, right? This formula is with us. So I have to first find the value of this I. How to find that? So let's see here, I value is equal to, or sorry, alpha is equal to I minus 1 by 1 by N minus 1 for association. So now if I substitute this one, 0.8 is equal to I minus 1 by 1 by 2. A dimerization means N value will be 2. So 1 by 2 minus 1. So this is minus 1 by 2 here. Minus 1 by 2. That means it goes up here. So I can have now 0.8 is equal to 1 minus I into 2. Okay, I just hope you understand this one. This will come minus 1 by 2, minus goes up, so minus multiplies inside, it becomes 1 minus I, and this 2 goes up. So I have how much this one? I can have 0.4 here, right? So now I value will be equal to 0.6. Okay, I have I value 0.6 now. Now let me solve here. What is delta TB? 0.3. Okay, KB, I value is 0.6. Kb value is 0.52, and molality 2.5 grams, right? 2.5 gram of the solute dissolved in the molar mass I have to find out, 1000 by 100. Okay, so I have 25 here, so I have to find this M here. Okay, so M finding will be 0.6 into 0.52 into, I have this one cancel, so I have 25 divided by I have 0.3. Okay, so I'll cancel this one. I have 50 here, 5 2s are 10, 25 plus 1 26. 50, 50, 5 2s are 10, 25, 26. I will have 2 point, sorry, 1 second, just let me multiply this one. 50, yeah, I'll have one more 0 here. So I'll get 26 as the molar mass, option number C here. Okay. Next, this is very important question and a lengthy question. Okay, so be a little bit patient here. So you have to take certain time to solve this question. Okay, so first of all, a sample of water is found to contain 5.8% of AB and 9.5% of XY2. So there are two types of solute added in the solvent. What is that? One is AB, one is XY2. Okay, and the assuming 80% ionization of AB. AB dissociates 80% and XY2 dissociates 60%. The freezing point of the sample will be, okay. Now see, till now we have done the questions with one type of solute, but here we have two types of solute. So what will be the formula? First let us know that delta TF is equal to I into KF into M. This is the general formula that we have. But now here we have two solutes and two I values. So here the formula changes a little bit, it gets modified like this: KF into I1 M1 plus I2 M2. Okay. So first what we will do, we will find M1 value, M2 value, I1 value, I2 value, substitute here. KF value is already given to us, and I have to find out the freezing point of pure water is also given. I have to find the freezing point of the solution, right? So let's start here with I1. So I have taken AB. First solute given to me is AB, right? So let it be AB. Okay. So for AB, what I have 5.8%, right? So that means, okay, what is the weight of AB? 5.8. What is the molar mass of AB? 58.5. Okay. Then can I calculate number of moles of AB here? Given mass by molar mass. So 55.8 by 58.5. Okay, this is 5. So just let us assume that this is 58. Okay, 58.5. Let us just assume it as 58 so that our calculation becomes a bit easier. So I can assume this like this: 5.8 divided by 58. So what I will get here? 1 by 10 or 0.1. Number of moles of AB is 0.1. Then what is the molality of AB? See, molality is what? Number of moles by mass of the solvent. So number of moles is 0.1 into 1000. Now see, when I am telling you 5.8% W by W, that means the mass of the solution is 100 grams. Out of that 5.8 is AB. Then what is the mass of solvent here? Mass of solvent will be 100 minus 5.8. That means equal to how much? I have 10 minus 8, 2. Then I have this side, so I'll just subtract here. You might be thinking ma'am is doing this subtraction also, but yes, it is very important to show each and every step here because this question is a bit lengthy. So I got 94.2, 0.1 into 1000 by 94.2, or I can write it as 1000 divided by 942. Okay, now if I solve this, okay, let's do division somewhere here. Just a minute. Okay, so I have to find out 1000 divided by 942. Okay, so I am just getting some space here. Just a minute. I am having some, I hope all of you have written this formula. Okay, so I want to calculate here 1000 by 942. Okay, so I have 1000 divided by 942. So definitely 1 I'll go, 942, 10 minus 2 8, 9 minus 4 5. Then I have that's all. Then I can add a 0 here. Then sorry, 1000 divided, yeah, I'm doing correct, right? So I have 8 plus 2 10, 9 10, and have a 0 here. So I will add here one more, this 0 will not be going, so I will add a decimal here. Next I will add one more 0. Next I think I can take here 9 2s are 18, 9 4s are 36, plus 1 37. No, I want. So now let's divide 1000 by 942. Okay, so I have 1000 divided by 942. So I will have first 1, 942. I have 10 minus 2 8, 9 minus 4 5. Then I will have, okay, so it won't be further divisible, so I'll add a point here and a decimal 0 here, again a 0 here, 0 here, then I can 6 will be there. So I can have this one as 1.06. So molality of AB I got. Now let's calculate this value. That let me just write down this formula for you people here. Yeah, what's the formula? I have delta TF is equal to I1 M1 plus I2 M2 whole multiplied with KF, right? This is the formula. So I got M of AB. Let's calculate I of AB, right? So what is the I value here? I value will be, you have to calculate alpha, right? So what is the, before that let's first calculate what's the value of alpha here. Alpha value given to me for AB is 80%, or I can write 0.8, right? So I have this formula, alpha is equal to I minus 1 by N minus 1, right? 0.8 equal to I minus 1 by, this is AB will dissociate into two particles, so 2 minus 1, that is equal to 1. So I have I value as 1.8, right? So I got M of AB and I of AB. These two values note down. Now we'll go to the next segment. Okay, so what I have got till now, M of AB is 1.06, I of AB is 1 point, how much I have got? 1.8. Okay, let's now draw for X, Y and 2. Okay, this is the next solute that I have. Here what I will first calculate, the same thing. First I will calculate the number of moles of X, Y, 2, right? What is the given mass? If you see, we have 9.5 gram and the molar mass is 95. So I have 9.5 divided by 95, same I will get 0.1. Next, what is the mass of the solvent? Mass of the solvent, that will be equal to 100 minus 9.5, right? So if I solve this, 10 minus 5 will be there, then I have 90.5, right? So I have 90.5 grams. Clear? Mass of the solvent I got, and XY2 I got. Next I want to calculate the molality, right? Or you can say the molality. Molality is equal to number of moles, that is 0.1 into 1000, right, by 90.5. Or if I solve this, I'll get 1000 divided by 905. Let's just quickly divide this one. 1000 into 905. I will have 905 here. 10 minus 5, 5, 9 minus 0, 9. So I have 95, then I'll put a decimal, then I'll put a 0 here. Then I can again go for 901.1, right? 10 minus 5, 5, 4 I have here, then I'll have a decimal 0, then I'll again have a decimal here again. I think then I can have 5 as a 25, 05 or 4, 1.104. Okay. Now let's calculate the I value. Okay, so what is the I value I have got here? So for I value, I first need to know the alpha value. What was the alpha value given for XY2? 60%, right? 0.6. So and we have this formula, that is alpha is equal to I minus 1 by N minus 1. So alpha value, that is equal to 0.6 is equal to I minus 1 by, see, X, Y and 2. So the number of ions produced here will be 3. So 3 minus 1, that is 2. And I have 1.2. So I have here I value, this is 2. Then I have this side, if I multiply 2 6 are 12, that is 1.2. 1.2 plus 1, that will give me 2.2. Okay. So now I have got I XY2 and MXY2. What is the value I have for that? I have molality of XY2, which is equal to 1.104, and have I value of XY2, which is equal to 2.2. Okay. Next I have here to calculate the value of delta TF. So you know, in 273, what is the freezing point of the solution given? 273, right? So I have, just a minute, yeah, so 273 minus TF I have to calculate. Kf value is how much? Kf value is for water is 1.86. Okay, then you have this one I1 M1, so 1.8 into 1.06, okay, plus you have this one 1.104 into 2.2, right? Now if I solve this 1.86, so this one I can almost approximate it as 1.8 plus I can just write 22 into 11, so that means 2.32, right? Wait, 22 into 11 I have to do. Just let me check this calculation. I'm taking it as 1.1 only, okay? So I will have 11 2s are 22, 22 plus 2, 242, right? So I will have, so 2 decimal places 2.42, okay? So now if I okay, 1.8, so I will have 2, 8 plus 4, 12, 2, 3, 4, 4.22 something, right? And if I just multiply this 1.86 into 4.22, you will get around, if I just multiply 1 I approximate it to 2, then I'll get somewhere around nearly equal to 8 point something I'll get, right? Okay, now if I got this one, now 273 minus this one I have to do, okay? So 273 minus 8 will be how much? Will be somewhere around 265, right? So 265 point something will come. So let's see the option. Yes, I have this option, that is option number B. Okay, be very careful with the calculation because we have A and B very close options. Okay, this was a lengthy question. I hope you have got it. Next, a non-volatile solute A tetramerizes in water to the extent of 80%. So alpha is how much? 80%. Okay, 2.5 gram of A in 100 gram of water. So what is the mass of A that is taken? 2.5 gram. What is the mass of the solvent taken? That is 100 grams. The freezing point decreases, so delta TF is equal to 0.3. Okay, molar mass of A you have to calculate and the Kf value is given to you as 1.86. Okay, so we have here formula delta TF is equal to Kf into M into I. Okay, first I will come. So first let's calculate the I value. So I have alpha is equal to I minus 1 by n minus 1, which is equal to 0.8 into I value is how much? I value I have to find out, sorry, n minus 1. So tetramerizes. So this is 1 by n. Whenever there is association, it is 1 by n minus 1. So tetramerizes means 1 by n, 1 by 4 minus 1. So I will get this one as 0.8 is equal to I minus 1 by minus 3 by 4. So it goes up 4 here, 3 remains here and this minus is there. So I can write this multiply 2.4 and I have minus 4, right? So I have 4 minus 4i. Okay, 4 minus 4i I will get. Now if I further subtract, this one will become 4i is equal to, I will get 1.6, right? Then I have I value equal to 0.4. Okay, so by calculating all these, this I value I got is 0.4. Now let's substitute the values for the other calculation. Okay, so what is delta TF value given to me? 0.3. I value given to me 0.4. KF, okay, just let me clear this board so that I will have more space. Just a minute. Yeah, 1 second. So we have just seen this I calculation is 0.4. Okay, I'm erasing this one so that we can do the rest of the calculation in this. So students, I hope you are getting this question. Any question you have doubt, please put down in the comment section. Now here's a question that you should remember, that whenever we have delta TF and delta TB, okay, you do not have to convert it into Kelvin. Delta TF and delta TB, the difference that will remain same whether you take in Kelvin or you take in Celsius. So the value or the difference to value should, the delta TF delta TB value can be either in Kelvin or in Celsius. You should not convert this 0.3 to you should not add here, because this is not the temperature, this is the difference between the two temperature, right? Yeah, so I can have the calculation now. So I value I got was 0.4, right? Now delta TF is 0.3, I value is 0.4, and I have KF value is 1.86. Molality I have to calculate, that is 2.5 by molar mass into 1000 by 100. Okay, that gives me 25 here. Okay, so I'll just solve this one. Molar mass is equal to 0.4 into 1.86 into 25. Okay, 0.4 into 1.86 into 25 divided by 0.3. Okay, m 0.3. Yeah, now I can solve this. So I have this one, 25 4za is 100, right? There's one decimal place, so it will become 10, so it becomes 18.6. 18.6, this one will give me 62, right? So the answer for this one will be option number A here. Okay, next we have osmosis. The swelling in the feet and ankles of an aged person due to the sitting continuously for long hours during travel is reduced by soaking the feet in warm salt. This is because of, so this problem is called as edema. Okay, this situation is called as edema, but when you put it in the warm water, okay, warm salt water, what happens? The swelling reduces. Why? Because the water retention, the water that is clogged comes out. Okay, this is due to osmosis, that is option number B here. Next we have, which of the following colligative properties can provide molar mass of proteins, polymers and colloids with greater precision? So this is an application of osmosis. We can use osmosis to calculate the pressure, masses of macromolecules. Okay, so here it is osmotic pressure. Let's see the next question here. If 3 gram of glucose is dissolved in 60 gram of water at 15 degrees Celsius, the osmotic pressure of the solution will be. Okay, so very direct question, we'll just put the formula here directly. So I have pi is equal to, oh sorry, one second, yeah, just a minute, yes. So yeah, I have this pi is equal to, what is the W2? Mass of the solute is 3 gram. 180 molar mass, 1000. Okay, then volume of the solution, see here it is 60 gram is given. For water the density is 1 gram per ml, so I can write it at 60 ml. Okay, then I have R value 0.083, and if you convert this 15 degree, so I have 15 plus 273, I'll get 288, right? Now let's try to solve this. So I have 3 by 180 into 1000 by 60, right? I can write this one as 83 by 1000 into 288. So we can do whatever cancellations we can. So let's cancel this 1000 and 1000. Okay, then I have 3 ones are 3 20s are, okay, then I can cancel here 6 3s are 80. Okay, and here I have 6 4s are 24, 48. Okay, further I can cancel 6 5s are 30, and I can cancel 6 8s are 48, right? So any other thing, so this if I round it off to 80, okay, just I'm writing here 83 into 8 divided by 5 into 20 I have, right? So I can cancel 4 2s are 8, 4 5s are 20. Okay, then I have here, so this one if I round it off to 80, okay, 80 into 2 is 160, 160 by 25, so 5 5s are 25, 5 3s are 15, I have 32, then I have 5 6 are 30, 6.4 something I'll get, or you can find the nearest answer is option number A here. Okay, next, which of the following pairs of solutions are isotonic? So isotonic, I told you, if the molarity is same, right? If the C value, concentration value is same, then the two solutions will be isotonic. Let's see for the option number A. So in option number A, you have 0.001 m of aluminium sulfate. Okay. Now if you see, aluminium sulfate will give you 5 ions, right? 2 aluminium and 3 sulfate. So if I multiply total, I'll get 0.005. Okay. Next we have BaCl2, that is 3, 0.01. I'll get 0.03. So these two are not equal. Next I have B here, 2 plus 1, 3, that is 0.003. And you have this one, 3 plus 2, 5, that is 0.005. Okay. Next C, I have 3 into 0.1, that is 0.03. And I have 3 into 0.001, that is 003. This is also not correct. Next I have 3 into 0.01, 0.03. And here if you see, I have 2 ions, 0.5, this one will give me 0.03. So you can see here the concentration is same, so it will be isotonic, option number D here. Okay, next, when the pure solvent diffuses out of the solution through the semi-permeable membrane, then the process is called. So you have here, see, this is like this. This side it is solution. Okay, and from solution side the water is being pushed out, pure water is removed from here. So that occurs in case of reverse osmosis, that is option number D. Next, osmotic pressure of the solution can be increased by. So we have this formula for osmotic pressure, pi is equal to C into R into T, directly proportional. So increasing the temperature. So if you increase the temperature, osmotic pressure will increase. Decreasing the temperature, no. If you increase the volume, so if you increase, what is concentration? Concentration is number of moles by volume. If you increase the volume, osmotic pressure will decrease. So no. Diluting the solution, that means also increasing the volume. So this will also not work. Option number A is the correct answer here. Next, 0.06% W by V aqueous solution of urea is isotonic with. So we can see first of all what is the molarity here. See, what is molarity? Number of moles. What is the mass of the aqueous solution of urea? W is 0.06. What is the volume of the solution? 100. Volume of the solution is 100. So I can have 0.06 divided by urea mass is 60 into 1000 by 100. Right? So I can cancel this one. I will have this 0, this 0. 6 ones are 6.01. So I will have 0.01 molarity. So I have to check where the molarity is 0.01. I can find here directly 0.01 is the option. So option number D here. Next, isotonic solutions have, this is by definition, same osmotic pressure. Okay, next we'll go to Van 't Hoff factor. We have already done certain questions of Van 't Hoff factor, but this is something very particularly to Van 't Hoff factor. Dimerization of the solute molecules. Dimerization, sorry. Okay. So dimerization, we have seen tetramerization, dimerization, that happens when there is hydrogen bonding. Okay, so option number A. Just a minute, yeah. Next question, among the following 0.1 m aqueous solution, which one will exhibit the lowest boiling point elevation assuming complete ionization? So lowest boiling point. So you have this one, delta TB is equal to I into KB into M. See, now all the solutions are having same molality, that is 0.1. I value, where the I value is least, there this delta TB value will be least, right? So here you can see the I value is equal to 5, here the I value is equal to 3, right? Here the I value is equal to 2, here the I value is equal to 4. So now you can see the least I value is for option number C, so that is why it is option number C here. Next, which of the following aqueous solution should have the highest boiling point? So if I want highest boiling point, what do I have? I value should be, you can see all of the concentration is same, I value should be highest. Here I value is 2, here 3, here 2, here 2. So obviously it is option number B, right?
Yes, so that's all students. In this we have solved 30 questions from last 2016 to 2025, almost I can say 10 years. So you can just practice these questions, brush up your concepts. Any doubt in any question, put down in the comment section. I'll definitely address to it. Okay, thank you for watching and all the best, and stay tuned for the next class.